All right, so I'm ready for some information. We're just going to look at A, and we're looking at it on the interval from -5 to 12. So what did you find? You did something, I think. What did you find for me? You found the first derivative, which is 3x squared minus 18x minus 48. Then what'd you do? Okay. X squared minus 6x minus 16. And what is it?
X minus 8.
Are people alright with that? So critical points at x equals 8 and x equals -2. And what? No. Alright. Are those on the interval?
Yes.
Alright, so these critical points are on the interval. And the question asks this time, not find the relative or the local mins or maxes or the critical points, but it says find the global minimums and maximums. And so this is a question that some of you actually had asked a couple days ago, like, how can you tell if it's the most or the least? And essentially what we're going to do is we're going to set up a competition. All right? And here are the players in the competition. Critical points get to contend, and end points get to contend. Okay? Do you agree that when we plug in -5, we might get something bigger or smaller than a critical point? It's possible. I like how you say that. Morgan's like, it's not necessarily, but it's possible. So, when we're looking at for global minimums or maximums on a closed interval, okay, so whoops. Oh man. There we go. Nope.
What are you doing?
I'm trying to erase. And it just doesn't want to at all. That's horrible. Yeah, what am I supposed to do now? I'm stuck.
You're supposed to not be.
Yeah, I know. This is bad. Bad day. Great. There we go. Okay. It's there, isn't it? Yeah, it's blinking. All right, so here's what we need. We need to actually come up with a chart. And our chart is x values and f of x values. And the players are critical points and endpoints. And we need to evaluate. So look, I'm going to use my graphing calculator. I could use a scientific calculator, but I'm actually going to check out what those values are. I have the function in my calculator, and I'm going to do vars y1 of 8, -396. It looks like we might have a front runner for minimum. Maybe. This actually gives us a pretty good idea if we want to go back to the window.
No, actually, wouldn't 12 be?
I don't know. I said a front runner. We have to see. All right, -2. 104. Maybe a front runner for maximum. All right. -5, which is an endpoint. Okay, we wouldn't have any reason to consider -5 other than the fact that it's the end point of this interval. -58. So -5 did not win. Now, we're thinking, David thinks maybe 12 will be a contender for the global minimum. Didn't make it. Didn't make it. So we do. We have a global max, and we have, yeah, that's what I meant to say. And now it's erasing. A global min and a global max. And let's, I'm just going to take a look at the window I'm going to look at the graph just to visually see that what I have is okay. So my window, I'm actually going to do my interval from -5 to 12, because that's all I really care about right now, right? Now my minimum, all right, and my maximum, like, it's got to be something big, right, above 100. And here's what the function looks like on that interval. So can you see that this does get global max awards and this does get global min awards? And as a matter of fact, this is also a local maximum and a local minimum. Is that okay? All right. Yeah, go ahead.
Wait, why can the endpoints be higher than, like, I thought the critical points were the only possible mins and max.
If you're on an open interval, those are your only possible local mins or maxes. If you actually think, if you go back to like a parabola, so that's a local, nope, that's not what I wanted to say. That's a local and global minimum, but the critical point here is not a maximum or a global maximum. As a matter of fact, this function doesn't have any global maximums. But what we're doing now is something very different. We're saying, look, we only want to look at a piece of the function. And when you only look at a piece of the function, the endpoints becomes players. As a matter of fact, let's look at B. Do my critical points change for B or C? No, but now all of a sudden 12 is not an endpoint. 14 is an endpoint. Do you think 8's going to lose its title? Or -2 is going to lose its title? I don't know. Let's see. Let's open it up to look at 14. Oh. Can you see if we go back and we do Y1 and we plug 14 in, it looks like -2 is going to lose its title. 360. So when we do B, so if we look at B now, all of a sudden, -2 still gets to keep its local maximum title. No one can take that away from it. Fought a good fight. All right, it's always going to be a local max. But now at 14 we have a global, and sometimes they call them an absolute. Sometimes they say it's an absolute maximum. On that interval. Yeah, that's good. I'm glad. That's always a good thing to say. When we're talking about a closed interval where there are endpoints, we'd say on that interval. And can you imagine, I can imagine, why would we have a closed interval? Well, if you think about problems where, like, it has to deal with your windpipe and we're, like, maximizing, the flow in our windpipe, or using a piece of paper to construct, like, using a piece of metal to construct a can. Most of those things are actually on closed intervals. You only have so much windpipe to expand. You only have so much material to make your can. So we're constricted by, whatever the constraints of the problem are. That was a bad use of English, sorry. All right, and let's see. Should we go out and just do C? If we go all the way out to infinity, now we're not on a closed interval anymore. We have a half-closed interval. So the question now is, the question now is, does -2, well, can -2, I think -2 already we know is going to get beat. I guess the question is, can 8 ever get beat? I don't know if it can. I don't know. Let's take a look. No, I guess not. It's a cubic, right? And so it's just going to keep going up. So -2 gets beat for its global max. 8 maintains its global min so long as what? How could we beat -8 if we wanted to? 8. Say again, Katie? Yeah. If we opened up the interval to the left, I don't know how far we'd have to go, but Katie said you could probably go out just a little bit more, and find something that would be less than that. So, look, not an earth-shattering class today, right? No, I wasn't, sorry, I didn't mean if it was good or bad. I mean, obviously it was a great class, but it wasn't earth-shattering in that all we really learned is that if you're talking about a closed interval, you need to think about endpoints. For right now, we would say that there's a local max at -2, and there's no global maximum, because the function just gets bigger and bigger. All right. Have a great day.